Time for another one of these revision videos. Someone asked me about periodicity. Now we all know the periodic table looks like what it does, 4 blocks. Periodicity is how particular properties change as you go horizontally. Now often the periodic table you look at vertical things, particularly at GCSE, you look at how trends within groups. It is derived from that. The periodic table has a history of piecing together a picture of what properties allow you to see patterns with and assemble it as a pictorial representation. Sadly, it was a failure to get it right for many of the pieces of the history, and it took the moment of deciding that there were perhaps, we don't know all the elements, and if we leave a gap in our periodic table for the elements that we think there might be one there and there might be another one there, then maybe the periodic table will work a little better. That was the work of Mendeleev. Left some gaps. Germanium was one of the elements that he left out. Made some predictions for it. Not spot on, but not too bad. So that modern periodic table, which sort of developed a little further over less than 100 or so years that followed Mendeleev, is the one that we pretty much see now. The extension of it with extra elements is kind of not really chemistry because they don't exist for very long. But what we're looking at here is, when you have the modern periodic table, do you get repeating patterns? Now this is not helped, but you can't avoid it. The change from metal to non-metal on the staircase line in the P block is gonna mess with some of the patterns sometimes, well, in various times. However, you can look at a number of things to try and show horizontal patterns that you can then repeat in the next period down, periods being the horizontal rows. And periodicity means repeating, because a period is a time period that something repeats in, like a pendulum, and it's obviously not a time thing in terms of chemistry, but it is a number of elements. So what can you look at in terms of trying to spot a pattern? Well, you can look at the structure of materials as a beginning, and they start off as metallic structures on the left and they end up as molecular structures on the right, but they do cross the staircase line, but each period crosses a staircase line at a different place. So you get different a different change position between those two when you go through giant structures. So it does to a point, but it's not fantastic. I'm slightly distracted because there's a squirrel about to go and take my bird feeders, but never mind. And slightly more successful is some of the other properties that you can look at. Now the classic A-level does it show periodicity is first ionisation energy. So first ionisation energy is the one that you see most A-level questions about, and it has a spin-off in terms of some other things. It's such an important thing to discuss at A-level because it gives you access to electronic structure, it gives you access to how orbitals are arranged, because we've got the blocks of S, P, D and F, and of course those are labelled after the orbitals that are last filled or partially filled or just finished being filled if it's right at the right hand end in the noble gases. So when you look at first ionisation energy, you get a thing that you see quite clearly, which is two, 3, 3. This 2 is the pair of s electrons as you come, because this is increasing atomic number, so these are different elements. This is not within one element. And what you get 2 s electrons, then you get 1 electron in the px one in the PY, one in the PZ. So this then results in half-filled P. This is more stable than this in terms of the energy it requires to remove that electron. Now there are lots of reasons for that, but the kind of think of it as the main reason is this is the first time you've had to pair up. So here you've got a pair of electrons in one of the orbitals, and one of those electrons will be repelled by the other one. So it's easier to get it out and get it ionised for the removal of that first electron. So here you get a little drop down, so you get sp, and then here you've got the doubling up in each of the p orbitals which you have there. So this is evidence for the structure of the energy levels and the orbitals within the atom, but it's also found in periodicity, because what you get is, if you look at the period starting with sodium, you'll see this 233. You go down to the next one, oh hold on, there's a thing that gets in the way. The thing that gets in the way is the transition elements, because the transition elements detract from what you're trying to see, because they don't follow the periodicity that you're looking for. So what you do is that you kind of go, oh look what they're doing, and you miss the repeating periodicity. So if you do need to print out the attached graphs that are with this video. If you haven't printed them, stop the video now and go and print them, because otherwise you won't know what we're talking about. And you've come back with them, or you had them already. Now, the graphs allow us to spot periodicity. There are two sets of graphs for the same thing. The first one is with the transition elements in, and you find the transition elements are not massively dissimilar, although there are patterns within it. We can see that in some questions that we'll have as well. However, the second set of graphs jump over the D block elements, the transition elements, and you can then more easily spot the patterns within the S and the P block, which is what we're trying to do at A level. So when you look at ionisation energy, you see this 233, and if you look at the graph of particularly the one without the transition elements, you'll see the 233 again. There are a number of other things you could look at. You could look at melting point. Does show periodicity, although not as clear cut as the ionisation energy. There's a little slight, it's kind of like nearly right. Boiling point is the same. Density also shows that, although of course, what do you measure the density of? Do you measure it at the gas, if it's a gas, at room temperature, or do you measure it as a liquid or a solid? Well, but it does show in that graph that's there some periodicity. And there'll be some questions where you can practice this, and you can present the evidence for that. And there'll be the answers with the sheet, so you can test yourself and then go and check that you've been talking about the right things. So let's just recap just for a moment. Periodicity is about looking at a row in the periodic table, a period, seeing the pattern and then moving down to the row underneath, and do we get the same pattern? And if it shows periodicity, there'll be close agreement. Although it doesn't always have to be perfect to say, oh, they're showing periodicity in the property you're looking at. Now the other relatively clear-cut periodicity example is the energy it takes to boil away a liquid element. Delta H boiling, or delta H vaporization in some terminology. And if you look at those, there is a definite up and down following the same pattern from one period to another. Like I said, two sets of data in the graphs that have been plotted for you. Second set, easier to spot the periodicity than the first set. Kind of all there really is to say. I suppose you need to do some practice at trying to word it. It is about how you word it. And you've got some questions to practice on. It's kind of it, really. You might have noticed, no edit in this. That's because my camera person is not here today. Thank you for watching. and I'll see you for another revision video very soon, because there's a whole list to do. Bye bye.